So a bit of housekeeping to get started. Please make sure to mute your lines if things are noisy or if there's typing in the background. We do want to facilitate conversation and participation for sure in this. Just make sure that you're being respectful of everybody. This talk, as we just saw, is being recorded. We will have some breakout sessions. Those are not going to be recorded, just for clarity. We'll be kind of getting feedback from that session and bringing it back to the main group, but we're not recording the breakouts themselves. Definitely, please use the chat to facilitate questions. Anything else we can do there. The Zoom chat is the right way to do that. We'll be watching and making sure we can answer questions as we go. So we'll get started and we'll go through the sort of overview of our agenda. So today we're going to be doing kind of a lightning talk format. We'll have 3 talks from some users and contributors in the Anchore open source. Each talk's gonna be about 10 minutes. Then we'll be doing a live breakout session. We'll be voting on the topics for that. So you'll see a poll go live here soon when we get to beginning those talks. It will end at the end of the second talk. We'll tabulate those results and then we'll create some breakout rooms with those results. And then we can kind of get together and discuss the interesting topics that you all want to learn more and share each other's information about. During that format, then we'll also, during that session, we'll get some representatives that will come back and report out, and we'll begin and we'll kind of share what we've learned in each of the breakouts. Then we'll wrap up, and towards the end, we have an optional extension time here if people want to hang out for a little bit longer and get to know each other, kind of talk about how they're using the different projects, what you'd like to see, participation options, things like that. So we have a great talk lineup coming next. First will be Alex Goodman, one of our developers and maintainers of Dive. He'll be talking about building more optimal container images. So the poll will go live here in a moment. So if that should come up in a moment, you'll see that pop in your screen. Oh, I see it. I hope everybody else does. You can answer now, or you can minimize and answer it during the talks, so you don't have to do it right now. But I will go ahead and hand off to Alex. We'll be talking about inspecting images with Dive. Alex, take it away.
Hello, thanks, Zach. Sharing my screen, 2 seconds. Okay, so I'll be talking today about building more optimal container images with Dive. So my name is Alex Goodman. Software engineer here at Anchore. Here's how we can find me and reach out. First, I want to cover very quickly, what is a container image? So very briefly, the shortest definition, it's a read-only template used to bootstrap containers. And to go a little further down that path, what actually makes up a container image? So it's made up of 3 things. One is that it has 1 or more archives that make up the root file system for a container. It has a description of how to create the container from the image, and also the steps that were taken to actually create that image. We're going to be focusing on the first one, the actual root files, or the files that are in that image. So when you are shipping a container image, you are shipping multiple layers or multiple archives. So when you have a Docker file that's describing how to make an image, and you actually run the build command and you get a container image, you get a set of archives, and each of those archives correspond to a particular action that you took in that Docker file. And so that's kind of key, and one of the key elements that you have to keep in mind when trying to optimize for size. So the goal is to make your container images as small as you can, because if you don't, your build times they take longer, deploy times take longer, you're having to store more data, etc. So the goal is to try to keep them as small as possible. So I'm going to show a few examples from Docker files of where the typical gotchas are. So for instance, here's a Docker file with a couple yum install commands. And so this is creating 2 layers, and it's duplicating content between those layers, in this case, the RPM database. So you really want to try to keep it into 1 layer if you're using, say, yum install commands. The same thing can be said for scripts or any other assets that you're bringing into the image. So here we're copying in the bytes, the file specifically, and we're choning it. And that's actually, the chown operation is duplicating the bytes from that you copied in from the first layer. So the goal is to try to leverage. Docker has an option to chown inline for when you copy in files. Oops, here we go. So for this last one, it's a lot harder to see. So something I want to point out is that static analysis tools looking at just the Docker file might not catch these kinds of things, because here we're copying in something into an app directory, or running a script, but it's not very apparent that the script itself has some content that may be duplicating files. So in this case, we're chowning recursively an entire directory, in which case we're duplicating that content in another archive, in a different layer archive. So the takeaway here is that spotting these inefficiencies is time consuming. It takes a little while to get used to looking at a Docker file and understanding that like what to actually look out for. So this is I'm a maintainer of the tool called Dive, and it's really built to help optimize for looking for these kinds of things, but not from a static analysis point of view for a Docker file, but instead the image itself. So there's a link down below. And specifically what it's really great at doing is being able to show the content in your Docker image layer by layer. It's able to show you what specifically has changed in those layers. And also try to give you a summary down to one number of like, what's your efficiency? Like how good are you so far at being able to store things don't have any redundant information. Dive is both an interactive terminal UI, so you can explore your image, but it's also a static analyzer of your image. So it'll give you a pass-fail that you can use in CI, which I'll show in a second. And so it's really great for trying to do like a quick build analysis cycle. Like you build your image, you run Dive to see like how good are we doing. You keep doing that until you find happy numbers, or you're convinced everything's as it should be. So without further ado, let's jump into a demo. I've got an app over here, and this application has a Docker file, and I've got that out here. I'm going to go ahead and just build that image, and we're going to run Dive to then see like what Dive can tell us about what's happening here. So here's run Dive on this image example, project latest in this case, grabs the image from the Docker daemon, and then we get a terminal UI. Okay, so what we're seeing here is on the left-hand side, a look at each layer in your image. And on the right, you're seeing the actual file content in each layer. So if I head over and I can scroll about here in the file tree, I'm only really interested in say, looking at like the modified files. So I'm gonna hide unmodified files and I can scroll about. So, if you see something in green on the right, that's something that was added. If you see something that's yellow, it's been modified. If you see something that's red, it's been removed. So there's a lot of information here, but looking around, there's a summary in this bottom left-hand pane that tries to tell you some useful bit of information. So like, oh, my image size is 550 megs, just shy of. But it looks like I've got an estimate of potential wasted space of 354 megs. Oh, geez, I've got some cleanup to do. So I'm at a image efficiency score of 67%. So let's see if we can find out what the problem is. So I could go to the Docker file and start trying to figure out exactly what's gone wrong. But I'm going to instead use Dive to kind of look around at some of these commands and see if anything pops out. And so I would say the first thing, so looking at the summary pane, I'm seeing a lot of paths that have occurred twice, 2 or more times. And it's all in this app directory, like /app. So that looks pretty suspicious. I also see something here that's called app snapshot dev assets, which doesn't seem right. I shouldn't have dev assets in something that's a production image. So that's a bit of a surprise there. So if I head up to the layers that we have, and if I start scrolling down, I'll see that here we've copied in the app, and that's 174 megs that we copied in. But if I go down to the bottom, it looks like we're doing a chmod recursive, and that's an additional 174 megs. That looks pretty suspicious. So we've got at least a couple findings here. One is this recursive chmod. We should try to eliminate that. And the other is, it looks like I've got some dev assets. So really quickly, just showing what that would looks like. Okay, looking about, I'm seeing we're copying in. Here's our chmod recursive. I'm going to remove this, but it was doing something for me earlier. Like it was actually making something executable, and it looks like it's this app Docker entry point. So I can instead say, hey, I want bash to run my Docker entry point, so I don't need to do a recursive. I don't need to chmod anything here. And additionally, it looks like, oh yes, I have a snapshots directory with this dev assets. So my Docker ignore should really be capturing this by saying, hey, I have a snapshot directory that I want to ignore during the build process. So let's see how we did. And before I kick off another build, I just want to show that there's also the CI mode, which is our pass fail. And I will demo that in a second, just to show a passing remark when I'm building an image. So make build image. Okay, so I've got my new image, and let's see if I can run dive. And I'm going to use the CI mode to get a pass fail. And something to note, now have a dive YAML that has a couple of rules. I'm only going to allow the lowest efficiency I'm going to allow is 95% efficient. And if there's any more wasted bytes than 20 megs, we should fail the build. So let's see how we did. So instead of getting this a terminal user interface, I'm expecting an immediate exit with a pass fail. So great, it's passed, which is wonderful. What are we at? So I scroll to the top. Looks like we were 98% efficient, and we wasted 6.6 megs, which is great. That's way down from like 300 some odd megs that we were at. The next thing I want to do is to put dive into CI and go from there, so I can make sure I don't keep running into these problems, or I can catch them as soon as possible. So yeah, that's all I have for the meantime. Thank you very much.
Great. Thanks, Alex. Yeah, I want to remind everybody, we want to hold our questions to the end. We'll get to them in the chat, and that includes the other one. But I see we have a great question from Wade, which is Dive capable of evaluating Docker files for Windows container images, Windows specific PowerShell commands, et cetera?
Oh, good question. So Dive, it doesn't actually necessarily look at the Docker file itself. It's looking at the image. And so as long as you can build an image, what it's trying to do is to see if there's any redundant paths. So the short answer is yes, it should work for Windows images just fine. Well, I haven't tried Windows images in a little while though. So, but yep. Great.
Are there any, what are good reasons there would be wasted space in an image, Alex?
That's a good question. So sometimes you do have some, like you may have some assets that actually need to mutate. I can't think of any off the top of my head. That's why it tends to be a pretty good indicator of wasted space. But it really is up to like the developer to say, is this wasted space or is this not wasted space? That's why it's really more of a heuristic than it is like a hard and fast rule. So I can't think of any off the top of my head to answer that question directly.
Great. One more might be, a lot of times we use Dive on tools, the images we're building, but you also have base images that you don't control the Docker files for, right? How would you kind of address that if you have a base image or image you're consuming that has a lot of wasted space? How might you help resolve that?
Yeah, there is a third option that I did not demo here that specifically only looks at the bytes in what I call like the user space. So it ignores the base image entirely. So you can say, I want an efficiency of X percentage, and it would not include the base image. So that would be the best way to account for that.
Great. And I see we have also another question from Pete, which is, does more efficiency equal more secure?
Oh, I wish. Unfortunately, it does not. So more efficiency really is just about storage. It's the storage size of the container image, which helps on build times, which helps on deployment times, but it definitely does not make your container more or less secure.
Great. Well, we're just about at time. I want to make sure we're moving. If there's any, we may have time for one last question if there are any. Otherwise, I think we'll go ahead and move on. Give it a minute. Anything else? Okay. Well, great. Thanks, Alex. Super interesting stuff. We love using Dive. It's a great tool. I've enjoyed it. I'm sure others appreciate it as well. So next up is Chet Burris from Cisco, a principal engineer working on some developer enablement tools in the security space, and he'll be talking about how they're using Sift at Cisco. Chet, you want to take it away?
Yeah, thanks, Zach. Let me go ahead and share my presentation here. Okay, so as Zach said, hi, my name's Chet. I'm a principal engineer here at Cisco. I work on a team that focuses on developer experience or developer enablement. I think that's a concept that some people are familiar with, other people aren't necessarily familiar with. So to briefly just touch on that, what we do and how that relates is we are a team of engineers. So we're software trained software developers and people with a lot of DevOps experience. And our job, or the products we make, is we build platforms and tools for our product engineers. To the goal being to try and enable our product engineers to focus more on developing the features and functionality that drive customers to our businesses, and less on things that are critically important, but don't necessarily directly, drive customers. So that's things like compliance and stuff like that. So, we like to say that we try and reduce the friction on our product level developers so that they can more easily achieve compliance. So since I'm going to talk about compliance, our lawyers require me to make this statement. Disclaimer, I'm not a lawyer, because compliance often involves legal things. So please be aware that this is based on my years and years of experience with working with lawyers, but I am not a lawyer. So compliance, and how does this relate to Sift? So there's a number of different things that compliance can mean. I'm going to kind of briefly touch on just a few of them. So first and foremost, there's this notion of open source software compliance. So this is a little bit of a soapbox of mine. A lot of people have this misconception that open source means it's free, I can do what I want with it. No, that's not what it means. Open source software is typically distributed under a license, and that license puts requirements on you, the developer who wants to use it, as well as you, the distributor, who wants to then redistribute that software. And you need to understand what that is. So frequently you can use it without having to pay money. So it's free in that money doesn't have to change hands, but it's not necessarily free in that it allows you to do anything that you might want to do. Linux Foundation has a great website that talks all about this, open source software compliance, right? Other types of compliance obligations that exist out there in different formats or different types of either company-specific standards or industry standards typically fall into two broad categories, which is ship only the software that you need, right? Don't ship software you don't need, and then keep your software up to date. So this is what we think of as more specifically like, hey, are you managing the CVEs that might exist in your third-party components? Are you keeping them up to date to address those CVEs, right? So how does all this relate to Sift and Anchore and what we're here to talk about? Well, so Sift is a tool for generating a software bill of materials. And so to accomplish any of these obligations that I've listed here, you need to know what's in your Docker image, and, where does it come from? What are the versions, things like that. And so that's where Sift comes in. It helps us generate this software bill of materials. So, real briefly, Sift can analyze containers either in a registry, from your local Docker daemon, or it can even analyze a Docker or an OCI image archive, something that's been like exported or saved. You can also look at a directory on disk. There's a mode where you can tell it, hey, just analyze what's in this directory. Tell me what you think is there. And then it supports, multiple different output formats. You can just get this pretty little list view. You can get a Json format, which is what my team predominantly uses there. And then it also supports this format called CycloneDX, which is an XML format. It's a software bomb standard that grew out of the OWASP community, and it's seeing some adoption. So how does Cisco use Sift? In a lot of different ways, actually. So one of the primary ways we use it is we can generate an SBOM during our CI process and include a report as part of the kind of pre-merge run for all of our PRs. And so this allows our developers to take a look at the content and see what's in there. make sure they're aware of what's in there. We also augment that with some data from about vulnerabilities from both Anchor and Gripe. And Gripe is the next talk that Dan's going to give. We also use it to store a permanent record of what was in any particular build. So when we do builds, we generate these SBOMs, we store them in JSON format, and now we have a permanent record of what was there at the time we built it. And we can go back and we can reference that JSON document and do post-processing on that JSON document versus having to grab the image, look at the image every time or reanalyze it, right? And so that's very powerful when people are starting to ask questions. What's in there? Did we ship this version? What version did we ship? We have these JSON documents that are in this well-known format that we can very easily parse. And we have tooling to parse that and help us analyze that sort of stuff. We also use it frequently to do ad hoc analysis of third-party images. We'll use both Syft and Gripe, again, this tool that's later going to be talked about, to look at their third-party images. Several of the products we ship it can be thought of as orchestrated platforms. And in fact, we support a couple of Cisco's SaaS offers as well. And so some of those can be quite large. And you can wind up with 50, 60, 70 different Docker images that come into play as part of these services. You have a bunch of microservices that you're running, providing different functionality. Sometimes you want to incorporate a third-party one. Hey, what's in this Kate CSI image? What's in this Prometheus image, or hey, we need Redis, so what's in this upstream Redis image? And so we can use that to evaluate upstream images to figure out, are the upstream images something that we're comfortable incorporating? Does it have problems that we think we can work with upstream to address, or do we just need to go build our own version of the image? And then finally, just to call out here, we also we use Anchor Engine and Anchor Enterprise quite a bit as well at Cisco for different things. And Syft forms part of the core content analyzer now as of Anchor Enterprise 3.x. And so we've been using it there as well. All right, so I'm going to try and do a quick demo here. Let me change. Okay, so I've got the latest version of Syft that just came out this morning installed on my laptop. I install it through Brew since I'm a Mac guy. It happens to be easy. And the Anchor folks always make sure that the latest Syft is available pretty quickly there, so that's great. So what I've done is I've got a very simple Docker file here that I'm going to use as an example. It's just Debian Buster Slim, which happens to be my favorite demo image, and we use a lot of Debian, so I'm familiar with it. All we're going to do here is we're just going to install Python 3 from Debian, and then I'm going to build a simple VM, and I'm going to install the request package, just as a real simple example here, right? So I'm going to go ahead and build that into my Docker image. And then what I'm going to do is I'm going to run Syft on that. So I'm building a local image, Syft_demo with the tag of latest. And what I'm going to do is I'm going to ask Syft itself to give me, to analyze it and tell me what's in there. So just Syft packages, because I want it to packages, and I'm just going to give it the tag, and Syft can automatically figure out if it needs to do a pull, it'll pull it. Since it's local, it'll just analyze it locally. So this is going to give me back a list of all the packages, their version, and the type. And so we can see here that there's a whole lot of Debian packages. Not surprising, it's a Debian image. And then we also see that there's a couple of Python packages here: pip, pkg resources, requests, right? And so this is great because I only pip installed one thing. I pip installed requests, but there's a bunch of other Python packages here. So if I do a grep for Python, we'll see that it comes back with 5 or 6, specific Python packages here. And that's because, as we understand, in most cases with most languages, we're talking like Node, Gems, Python. When you install one thing, it's got other dependencies, and that gets pulled in. That can sometimes be difficult for developers to understand. So Syft is clearly sitting here showing us that, you installed one thing, but really what happened is a bunch more stuff wound up on disk, and here it is, right? As I mentioned, there's also other formats. The one we predominantly use is the JSON format, and there's a lot of great data in the JSON format. I just want to show this real quick because it also happens to be a good setup for Dan's Gripe talk. But what you see here in the JSON format is is first off, you see this locations block, which is an indication of what it was that Gripe found in the image, or sorry, that Syft found in the image that made it think that this package was present. So if sometimes you're looking at something going, why does it think this component is present? I don't know where this is coming from. You can look at this JSON data and say, oh, well, these files are an indicator to it that this package is present. The other thing that we really like and will frequently use the Syft data for is it includes the CPEs here. Dan will talk, I think, a little bit about this as it relates to Gripe. This is vulnerability matching data, and it helps to tell you, hey, this thing that was found, how would it be matched against vulnerability feeds? And so if you're looking at things like false positives for vulnerability data, using Syft to figure out what and how this would be matched can sometimes be super helpful. And then finally, there's this files block here, which is useful because it shows you all the things that Syft thinks is part of this singular package, right? And so sometimes you have multiple things that are part of that. The other thing that I'll show real quick is I mentioned that Syft has this way of doing, it can scan a directory, right? So I'm going to do basically the same thing that I just did in the Docker image here. So I'm going to set my local version of Python to 3.9.5. I use PyM to manage that. I'm going to make a Python virtual environment. I'm going to install requests. And now I'm going to tell Syft, I'm going to tell it I want it to scan a specific directory, which happens to be the directory I'm in right now. And it's going to scan the directory, and it's going to come back and tell me, hey, you just have these Python elements here, right? And that's super useful as well. So Syft can be used at development time, right, to look at things like a virtual environment that you're doing development out of, say a node modules directory or something like that, and give you kind of this view, even for the developers during development time of like, well, what's going on here and what's present. And that's another really useful way that our developers help kind of manage their dependencies and make sure they don't have anything bad that gets in there or unexpected that gets in there. So I will switch back to the presentation, and just to call out, if you want to get engaged in the Syft community, it's up on GitHub. It's one of Anchor's open source projects, so they're always looking for contributions and want you all to get engaged. So cool, thank you.
Great, thanks, Chet. Much appreciated. Great insight into how you guys are using it and some of the features and stuff of Syft as well. Love to see the kind of value that you're getting from that JSON output. We put a lot of thought and effort into that stuff for sure. We did get one question from Lito Wang. Which is for Syft, what kinds of analysis does Syft do for third-party images? So I think you touched on some of that there, but if you want to address it directly.
Yeah, I can talk a little bit, and Dan, who's one of the lead developers on Syft, and I know Alex works on it too. If I misspeak, please hop in and correct me here, since you all are the experts. But yeah, for third-party images, if you just do a Docker pull, you download something from Docker Hub, Syft can still take it apart. You don't need the Docker file at all. Maybe I should have shown that in the demo, right? But Syft is able to analyze each of the layers that make up the image and apply those content analyzers to determine that content. It doesn't need the Docker file at all. So, for third-party images where we don't have the Docker file, we use it to figure out what's in there to make sure there's nothing lurking in there that creates either a license issue or a security issue for us.
Great, thanks, Chet. Up next, we have Dan Luring on the Anchor team coming up. But before we do that, I want to do a quick check on the poll. So I think we've got pretty good participation on the poll that was run for the topic for our breakout sessions. But we'll be closing that poll here in like a couple of minutes, or a minute or so, maybe a little bit less. So if you haven't yet voted on the topics for the breakout sessions, please do so like right now, and we'll be closing that very shortly while Dan's talking, and then we'll be presenting the results after his talk, and we'll transition into the more active participation where we'll all get to share our challenges and triumphs together. So it should be interesting. So I just want to highlight that. Up next is Dan Luring on the Anchor team, where he works on the open source team, helping build Syft and Gripe and managing what that team is working on. And he'll be talking about how using Gripe in the 3 ways to use it in your CI pipelines. So I'll go ahead and hand it off to Dan.
All right, awesome. Thank you, Zach. Let me share my screen here. All right, so you can see my screen, hopefully. So this talk is fast container scanning. And we're going to look at Gripe in particular and 3 ways to use it that I think are worth sharing. So my name is Dan. I run the open source engineering component of Anchor. And if you have any questions or want to just chat about anything, please feel free to reach out to me afterwards. Here's different ways to get in touch. So first, before we talk about how to leverage Gripe for various use cases, I wanted to do a quick overview of what Gripe is in case you're not familiar. So Gripe is a vulnerability scanner, and it's a CLI tool scanner. So it's not a service you have to host or anything like that. It's just a command you can run on the CLI and point it at something, and it'll scan for known vulnerabilities. What do you point it at? There's a few options. You can point it at container images. You can point it at just directories, kind of like the Sift flexibility that Chet was showing. And you can also point it at SBOMs or software bills of materials. And we'll look at that in particular. That's kind of exciting. But yeah, Gripe is fast and it's really easy to integrate. So there's lots of configuration that's exposed through config files or through environment variables. And there's also lots of flexibility with how you can have the data come out of Gripe. So has lots of output options, but you can also just define your own template and then output in exactly the format you have in mind. And then, yeah, here's the GitHub link. So please check it out. Check out the releases, check out the traffic in the Git repo. Let us know what you think. All right, so quick demo of what Gripe is, and then we'll go from there into the workflows. So here we go. I have a little sample project here. So kind of a dummy node or npm project. And we have a Docker file. We have some packages defined in the package JSON that I previously npm installed. And so the first thing I'm going to do is go ahead and build this Docker image. So I'll do that right now. Cool. So I have my Docker image. Now that I have this, I want to go ahead and try out Gripe. So I'm going to have Gripe look at that image, and I tagged it as sample app latest. So we'll see what Gripe says. So you'll notice it's doing a few things. Gripe is looking at the software that's installed with the container image, kind of like Sift does, but it's also needing to access vulnerability data because it's doing a comparison between the two. So it's for any given package, what vulnerabilities are known about that package at that version. So here's the output. So right away, we get sort of a summary table view. And so we can see each vulnerability that was found within that container image. And this is really good to know. So I can see which packages are affected. So I see Lodash has several of them here and a few others. I can see the version of Lodash I have installed. And in fact, I can see that for some of these vulnerabilities, they've actually been fixed in a later version of this package. So if I'm able to upgrade that package, I'll be able to resolve the vulnerability. So that's pretty important. And I also see the severity, of course. So how impactful is this? Is this a big deal? Is this maybe it could be triaged later? But one thing you'll notice is that this is a very high level representation of the Gripe analysis. So we actually have multiple ways to show what Gripe knows. In fact, Gripe has a -o JSON, just like Chet showed Sift having. So we can rerun this command, in fact, and do -o JSON. And we'll check out what this does. It'll redo the analysis. But this time it's going to output in JSON format. And this is everything Gripe knows about. There's actually a ton of information here if you have a need for it. So we have a list of all the same matches, but for each match, we show you a whole bunch of things. Number one, we show you much more about the vulnerability that we're actually reporting. So here you can see the ID, of course, but now you also see the data source where Gripe ultimately gets this information from. You can see related URLs, the full description. You can see CVSS data, fix information. And you also get to see more information about the actual software itself that's installed that Gripe is flagging as vulnerable. So you can see, here's more about it. We found this npm package called Lodash at this version, similar information that Chet showed from Sift. So you can see exactly like where in this image are you saying this package is installed? Like, because these are the kind of questions, if you really do need to patch the vulnerability, you're going to want to know these answers. We also expose information about how we determine the match. So Gripe is kind of showing its work in like a math class. How did you get to this conclusion that this software is vulnerable in this way? And so the match details kind of provide insight into how it did that. And again, like Chet mentioned, we can look at how CPEs played into the matching, for example. So that's the JSON output. There's one other thing I want to highlight before I get into the 3 workflows that I think is some good context. And that's that we have a flag you can use -- fail on. And this is really useful if you're using Gripe in CI pipelines and you want the pipeline job to fail explicitly if there is a security concern. So try this again, but instead of all this, I'm going to do -- fail on. And this allows me to specify a severity where if that severity or higher is found among all the reported vulnerabilities, Gripe will still show you all the same results, but it's going to exit one. So it's going to return an error basically. And of course, you can use that in CI pipelines to trigger a job failure. And that way you'll know like, oh man, this is there's a problem here that's not acceptable based on how I've defined acceptability. So in this case, I'll specify the medium severity. And we see here, again, you see the same output, and you can show any output you want here. It doesn't have to be the table view, but you'll also see this error message, discovered vulnerabilities at or above the severity threshold. So we specify medium, and sure enough, this container image has vulnerabilities that are medium or higher. In fact, it has medium and high and critical. And then, just to double check, we can see the exit code was 1. So this would be really handy if we wanted to integrate this into CI. Okay, with that kind of high-level overview of Gripe, I want to talk about these 3 workflows that we think are worth mentioning. So let me go back to the slides. 3 ways to use Gripe. Number 1, build image, then scan. This is pretty traditional and a really easy way to integrate security into your pipeline. So the idea is you probably already have this first line in some sort of CI file of yours. So Docker build from the current context and give it this tag. So with this workflow, all you have to do is add 1 new line, and that's Gripe, point Gripe at that container image you just built. And in this case, use that CI flag we mentioned, -- fail on, to specify some sort of threshold above which you want to start failing the pipeline. So this is a great way to take the first step into security for your pipeline. So if you don't have anything like this today, this is a great way to get way more assurance about the security of the image that you're building and presumably also deploying way upstream in the CI pipeline. So it's pretty simple and it fits nicely into existing workflows. All right, that's number 1. What's number 2? Scan while building. This is an interesting twist. So this is talking about the idea of adding Gripe into the process of building your image. And so you can do this with a multi-stage Docker file, for example. So you can have a first stage, for example, that's assembling the components of your app. You can have a second stage where you're actually bringing in Gripe and running Gripe, and again, using that fail on flag. And then only if that passes will the build continue into the third stage where you're bringing those scanned assets over to create the finalized image. This is really intriguing because it's kind of the first instance of in this demo of shifting left. So with this setup, with this approach, you actually cannot produce insecure images where that's defined by failing Gripe's test. So you will not end up with any images that don't meet the criteria you specified here in that Gripe line. And that can be really powerful because then it avoids a whole class of mistakes where you have these images and you meant to scan it before you push, but maybe one got pushed and made it downstream. So this is really cool. So 1, it shifts left. The other cool thing about this is there's more files that are visible, of course, throughout the process of building the container image than are necessarily available at the end of the image building process and available into running containers downstream of that. And so it gets really cool because you end up giving Gripe more visibility, perhaps, into parts of your build process. And so there's more reasons Gripe can consider for flagging vulnerabilities in your image. For example, if you have references to libraries that are being incorporated into some sort of build process, but there's no other record of those libraries in the final container image. So there's nothing for Gripe to see maybe in that scenario for the final image, but it does have a chance of getting more information if it can be visible to Gripe in this container image building process. So that's pretty cool. And then the final one, we're really excited about this. We think this is the future. SBOM once, scan repeatedly. So what does this mean? So as Chet was showing you, SBOM, software bill of materials, that's a record of the software that's installed in a thing. And that could be on a file system, in a container image, what have you. And so this is an interesting slight twist to that first workflow. Look at this. So we're building the image just like before, but after that, rather than scan for vulnerabilities, we're running Sift. And Sift doesn't scan for vulnerabilities, but Sift does show you everything that's installed in the container image. So we'll run Sift pointed at the container image, and save that Syft output as a JSON file. Excuse me. And we'll persist that, and then we'll feed that SBOM into Gripe. And so Gripe, just like you can look at container images and you can point Gripe at just a directory on your file system, you can also feed these Syft SBOMs into Gripe. And that's really cool for a number of reasons. One, it's way faster. It avoids this costly imagery inspection. So Syft does some of the hard things that now Gripe doesn't have to do. So Syft was in charge in this scenario. It was in charge of pulling the image, breaking that image archive apart, looking at all the file systems that are inside there, looking through the entire file tree for various signs of packages being installed. We get to sort of skip past all of that in this workflow because as far as Gripe's concerned, this SBOM is sort of a lossless representation of the software installed in the image. So you don't actually need the image anymore. You can have a SBOM file that's directly correlated with that container image and have that be the input for Gripe. And so here you can see that we can point Gripe at that SBOM file and just point it to a file path here and run the same kind of CI workflow. And it's just as good as if you had run Gripe on that container image originally. There's one other huge benefit about this, and this is the second bullet point here. This enables you to have a really easy way to detect new vulnerabilities for a container image that are discovered after you've already done your image building and all your checks, and probably even after you've deployed that image as a container into Kubernetes or something. So this makes it really easy to set up recurring pipelines, things that are running every day perhaps, or every week or twice a day, whatever. If you can routinely point Gripe at these SBOMs, then that opens the door for you to realize, hey, there are new vulnerabilities that were discovered after the fact, after I did my initial scans, and I've already shipped my image. I can now realize there's a new vulnerability or several vulnerabilities discovered that still affect my production environment right now, because these are vulnerabilities found in those images. So this is really neat. And we think this is sort of the future. We think the more folks get familiarized with SBOMs, the more they will hold on to these SBOMs for various points of their kind of DevOps workflow. And they'll use these as outputs for build processes and also inputs for other checks, like in this case, vulnerability scanning. So with that, those are the three workflows I wanted to show you about. So number one, build image, then scan. Number two, scan as part of the building process. And number three, capture that SBOM and then repeatedly check the SBOM for vulnerabilities. That's it.
Great. Thanks, Dan. We've got a few questions that I want to get to, but I want to kind of do a quick time check. So we'll kind of have to move through these a little more quickly, and then we can also follow up to answer these questions in the chat. So I want to give you time to directly address them, but if there's more detail we want to provide, we can do it on the chat side. The first one was, let's see. Kind of how has Gripe different from some of the other scanning tools out there? The Anchore engine, Twistlock, Trivia. There's a couple mentioned there. How do you think it's unique in that space?
Great question. So there's, I think, a few different classes of vulnerability scanners. So there is a large number of hosted offerings, and there's different differentiations for like the Anchore, the traditional Anchore engine or enterprise kind of scanning, things that Gripe cannot do. Because they are hosted, they can remember things. You can have, automatic pulls and that sort of thing. Gripe is really great for a local scanning of an image. So you've built the image, and then right away you want to assess that image before it's even left that CI system or from your local dev system. That being said, Gripe's not the only one of that class either. So within that class, you'd think that having software and having vulnerability data and just finding the overlap would be straightforward and commoditized. But in our experience, the devil's in the details. So there's all sorts of vulnerability data sources that you can have, that you can sort of curate. There's all sorts of matching algorithms that you can apply to seeing what software is actually vulnerable. There's that confusion matrix of false positives, false negatives, et cetera. So it turns out to be really important to get that right, or you're just producing a bunch of junk. And so you're showing vulnerabilities, but they may or may not be what you want to assess. The other thing we're really trying to do with Gripe is make it really like ergonomically friendly. So we're really trying to make sure that it's performant, it's easy to use, the options make sense, it's easy to integrate. We're really excited about focusing on the user experience, and that's probably where we think Gripe is most differentiated.
Great. Thanks. I think it's all in terms of the Anchor ecosystem as well. I just want to highlight, right, the Gripe is local. It's not a connected API service, right? Whereas Engine and our products are about a centralized kind of service that you can host and share across orgs and have those other attributes. Whereas Gripe is very much optimized for local use, being very fast and in your pipeline itself, as Dan was showing, kind of the quick time to result. Great. So I think we have a few more questions, but I want to do a quick time check because we're really getting close here. So we want to do we'll follow up with those on chat, and we'll see if we can move on and go ahead and get on to the next section, do our breakout rooms. Great questions though, and we'll get to all of those. They're really important. I'm going to go ahead and share just kind of the intro to the breakout session and our polling results. I don't know if Brian, if you can pop those up. There we go. Great. Excellent. So you should be able to see the results. So we'll have 3 breakout sessions. We want to make sure that we have time for us to kind of all come together and talk about these issues. So the ones that we'll be doing are the, as you see there. So we'll assign kind of moderators and we'll help focus the discussion there. We'll go in and we'll have a facilitator. We'll discuss the topic for about 10 minutes. Because of time, I don't think we're going to be able to do the readout section. So we'll just kind of take notes and make sure we can follow up and address any questions there. On the screen I'm sharing, here's a quick guide on how to join a breakout room. So there's a little breakout room thing at the bottom of your Zoom screen that should show how you click and you go to the right-hand side and click which one you want to join. So there will be 3 that are active, and you can kind of pick which one we want to go and join, and we'll kind of meet everybody there to discuss the specific topics. And then we'll come back here. There's a leave room. Make sure you don't leave the meeting, but leave the room, and it'll come back to the main meeting, and then we'll kind of wrap up with follow-up steps, including like how we're going to be sending out the ebook and stuff like that, so everybody can understand the next steps. So we'll go ahead and open up those rooms now, and I'm going to stop sharing my screen. Great. So the topics, we have the container security in Kubernetes, moving security left, and adding sec to DevOps. I will see you all back on the main one here shortly.
If you guys are coming back here into the main room from your breakouts, we're just going to give it a couple of seconds for everybody to make their way back in. It looked like we had one giant breakout around Kubernetes image security, so maybe taking them a moment to get back together with us. All right, looks like Zach, you've got control of the screen again.
Yes. Great. Good discussion. Had a lot of interesting questions and follow up on the Kubernetes side. So thanks everybody for participating there. But I want to be sensitive to time. We're coming up on our hour. So overall, great. Thanks for attending. We really appreciate it. We definitely want to call out, we'd love to continue collaborating and working with all of you even more. So, if you're not aware, we have a Slack channel and a Slack community that you're all welcome to join. A bunch of us at Anchor on the development side are on those channels and happy to talk and discuss technical issues, collaboration and participation in the projects themselves. And you can get an invite to that community via anchor.com/Slack. And here on the slide in the top right, we also have the Github locations for Gripe and Sift specifically, as well as Alex's Dive project. So, we're always looking for collaborators. We build our engineering processes around open source development. So we are good at getting PRs through and understand how to do that, and happy to have you join us there. If you're already a member of the Slack community, I'd love, it'd be great to join the announcements channel. It's a channel we just created to help announce events like this and make sure that people are able to follow along with what's happening. And you can use Slack or directly with GitHub issues, either way, to kind of reach out to us if you're interested in participating, learning more, or helping to develop code, find bugs, any of those things. We're happy to hear more about it and engage and help move the projects forward. We also definitely would appreciate GitHub stars to help promote the projects to other folks, make sure people are aware of these tools. If you're really enjoying them, that's a great way to kind of help support our effort and make sure that other people can find these as well. And we'll also be at KubeCon. So again, we had lots of Kubernetes discussion here, but we will certainly be at KubeCon in Los Angeles this year in October. So if you're interested in coming, we're planning on having a get together during that time. So if you're interested, ping us either on the Zoom chat or catch up with us on Slack if you're going to be attending, and we'd love to kind of get a group together. And we'll also be at the pre-meeting days of the 0 days and such. So we'll be around that whole time, and we can follow up. If you want to speak at a future meetup or interested in presenting here with how you're using Anchor or other kind of technologies in the space, we'd love to have a discussion there. Ping us either in the chat here or come mention it on Slack, and we'd love to talk about that. And in terms of the follow-ups, everybody should be receiving an email that'll have links to a survey, both on the format, like how this meetup went. We'd love to make the next one even better. So give us your brutal, honest opinions. We'd like to make sure we're making good use of your precious time, as well as instructions on how to get the ebook and the slides and videos of today's presentation. So there will be that stuff will be following up to the email that you registered with. So that's it with our official time. I think the Anchor folks will be around for a bit longer, so we can kind of continue chatting. And if there's any questions you want to answer and things you want to learn about, we're happy to do that. We'll stop the recording for that section, but we can kind of go long if anybody wants to connect anything. We've got another 20-30 minutes scheduled for us that we can be available. But other than that, thank you everybody for attending. Much appreciated, and have a great rest of your day.